Hello guys, so today we'll be continuing our journey of motion with respect to graphs, because as we have already known that graphs are that part which needs to be understood very precisely, so that the problems in physics can be done in a much easier way, and also we should not feel afraid of graphs, right? So in motion chapter we have already started how to draw graphs and all. Today we will discuss different types of graphs based on various physical quantities. So first we are taking distance time graph. So if you see, distance time means distance is a scalar quantity. Distance is what type of quantity? It is scalar quantity. Okay, so this thing needs to be kept in mind. So suppose a body is at rest. Suppose a body is at rest. Okay, body at rest. Body at rest. So how will the graph look like if I try to plot distance versus time? Distance versus time. So if the body is at rest, there can be two things. The observer will sit over here. So if the body is initially at the position of the observer only, that means distance of the body from the observer will be 0. So body will start from here and the path of the body will be like this only, because body is not moving. So basically if the body is not moving, that means distance from the observer is 0. So definitely there is no change. However, if suppose the body is initially at this position and here is my observer, so already there is 5 meter distance. Already let's take 5 meter distance from the observer. Then after time t, time 1 second, 2 second, 3 second, the body is not moving, so the distance of the body from the observer remains same. As the time increases, the distance doesn't change. It is still 5 meter, whether it is 0 second, 2 second or say 4 second, the graph remains a straight line parallel to x-axis. Please write this down. It is a straight line parallel to x-axis. Okay. Now let us take that the body is moving with a uniform speed. Body is moving with a uniform speed. Body moving with uniform speed. That means speed is constant. So if v is constant, what does that mean? That is, change in distance by change in time is constant. Okay, change in distance by change in time is constant. What does this mean? Again I'll ask you, what does this mean? If velocity is constant, then can I write s is equal to v into t? Now if I plot distance versus time, see, this equation can be written as vt plus 0. This is falling in y is equal to mx plus c. And here, as the velocity is constant, in x-axis there is t, right? This is t. And in y-axis, this is y-axis it is s. See, this is s, okay? So it is falling in the equation of straight line. And if you see this, here the intercept, that is c, is equal to 0. So the line will pass through the origin. Straight line through the origin. Okay, you can write this down. It will be a straight line passing through origin. However, if the body was originally say 5 meter away from you, if the body was originally 5 meter away from you, that can be a case, then also it would have been a straight line, but that initially at time t is equal to 0 second, the body was already 5 meter away from the observer is over here, so this would be the case. Clear? Now I'll do a very small problem over here, combining all the concepts that we have already done. See, suppose in the same diagram I have given the angle with the horizontal is 30 degree. Angle with the horizontal is 30 degree. Now find speed. So see, if we go into this formula, then we know S is equal to V into T. Okay, so if S is equal to V into T, then we know the slope. How to find out this slope? Let us try it. S is equal to V into T. In x-axis we have T, in y-axis we have S. So I can write y is equal to m into x, right? Now the question is, this line does not pass through origin. And the body is already 5 meter ahead of the observer at 0 second. So if I calculate velocity into time, distance is equal to velocity into time, that will give me the equation of this one, that is correct. But originally the distance is 5 meter, so originally whenever the time is equal to 0, see, if you put time is equal to 0, distance will come at 0, but actually it is not 0, it is Vt plus 5. Now if you put t is equal to 0, then also you will see you will get 5 meter, which is correct, right? It will be 5 meter. So here we have some c, that is c is equal to 5, that is why it has intersected over here. Clear to everybody? This is a very important concept which I discussed via an example. Now my question is how to calculate speed. So here we can see this slope corresponds to V. So slope, m is equal to slope is equal to how much is V. Now how do I calculate slope? I calculate slope by tan theta. What is theta given? 30 degree. So here it is tan 30 degree. Tan 30 degree is equal to 1 by root 3, and it is what it is, 1 by root 3 meter per second. So here's how you have to combine trigonometry with coordinate geometry, and also the motion is coming together. So little by little I am introducing to you the applications of mathematics inside physics. That is what my intention is. You may face a little bit of difficulty at the initial phase, but when we will be solving lots and lots of problems like this, things will get easy. Okay, things will get easy. So let us go for another problem, so you gain more confidence. Suppose I have given you a graph over here. Okay, this is distance by time graph, two distance by time graph like this. So this is 30 degree, this is again 30 degree. This is distance, this is time. This is for car A, this is for car B. This problem was asked in NEET examination. Okay, so let us discuss this. This is an easy problem, very easy problem. See, now if it is asked what is the speed of car A, so first of all I have to find out speed is slope of distance time graph. So the slope over here is tan theta. Now what is theta? So this line is for car A. The total angle with the horizontal is 60 degree. So tan 60 degree. So this will be root 3 meter per second. Okay. Now speed of car B. This should be tan 30 degree, because angle of car B is 30 degree with the horizontal. So this will be 1 by root 3. So guys, it is very important that you remember the standard angles and their tangent, sine and cosine. and we have to combine all this together in solving physics problems. Okay, so one by one we are going to do lot of examples, and you guys are going to feel confident as long as you are with me, as long as you are going in a way that I suggest you. Okay, so suppose now I am talking about a distance time graph where there is no uniform velocity, no uniform speed. So non-uniform speed, non-uniform speed. So it may happen that speed is either increasing or decreasing. Speed is either increasing or decreasing. If speed increases, we are talking about distance time graph. We are talking about distance time graph. If speed increases, okay, we need to understand this. Increasing speed, what does this mean? Speed is the slope of distance time graph. So increasing speed essentially means the slope increases. Decreasing speed essentially means the slope decreases. So how should the graph look like? If this is the increasing one, the first one, then we should increase the slope. As the slope increases, line goes closer to x-axis, like this. This is increasing speed. Increasing slope. Line becomes more steep. Slope is increasing. Line becomes more flat. Slope is decreasing. So this is decreasing. This is increasing speed. End of the story. Very simple. Everything is just the play of coordinate geometry, nothing else. Okay, nothing else. Play of coordinate geometry. Can anybody say now, if I draw a graph like this, definitely distance time. Okay, what does this mean? Let us analyze this. Here time constant, that means time is not changing, distance is increasing. Is this possible? With no time change, a body is moving away from you, but the time remains same. Is it possible? No, not possible. Time must change, bhai. How can, if the time remains constant, then nothing else can change, right? Nothing else can change if the time remains constant. Clear? Let us go for another one. Okay. Let us see if this is possible or not. If this is possible or not. So see, the first one, as the time increases, here what is happening? Time increasing, distance is decreasing. Is this possible? You may say, yes sir, it is possible. Time is increasing, body is coming towards me. But remember, if the body comes towards you, in case of distance, it is a scalar quantity. If the body is traveling whether towards you or away from you, the distance should not decrease. Distance, if this is the point, this is a point like this, if it happens like this or it happens like this, you should calculate the total path and say the distance. So suppose when it is displacement, I am going like this, I am coming back, definitely displacement is equal to 0, but distance is equal to 2x if this is x. Correct? So distance has to increase if time increases. It may remain constant, it cannot decrease. So this is not possible. This is absolutely not possible. Okay, next, this one. Okay, this is S. See, at same time a body is at two positions. Not possible. At same time a body cannot have two positions with respect to the observer. It is not possible. Okay? If this would have been possible, then everybody would have been God, right? they are available in USA, you are, and at the same time I am available in India. Everywhere I could be present. So this is not possible. Distance cannot have two coordinates at the same time. So this is absolutely not possible. ठीक है? Okay. So distance time graph we have discussed with lot of examples today, as you can see. So, and we have done two problems also. But does that end it? No, there is another thing that is called displacement, which also we have done in earlier class also, but I am going to revise this again because this is very important. Graphs are basically backbone of physics and in some cases chemistry also. So now we are going into displacement time graph. So one by one I am going to draw some graphs first and then we are going to explain all together. That will be easy because this is basically a revision class. We have already understood what is graphs. So first, if it is like this, what does this mean? Body at rest. Write down body at rest, and definitely body at rest, but at t is equal to 0 it has a position away from observer. Okay, next, if this is the graph, this one, let's make it another color. If this is the graph, then it is also body at rest, and that's it. At t is equal to 0 body is at same position as observer. Okay, next, if a body is having uniform velocity starting from the position of the observer, so this is simply uniform velocity. This is simply uniform velocity. Okay, what about this? The slope is increasing. Slope increasing means increasing velocity. What about this? Decreasing velocity. Slope is decreasing means decreasing velocity. Okay, what about this? What about this? Here the slope is negative. Slope is negative means velocity is negative. Velocity is negative means the body is traveling towards the observer. Displacement is decreasing. Displacement is decreasing as time is decreasing. See, similar kind of thing I have done over here in this one in case of distance. However, distance was a scalar quantity, so whenever time increases, distance cannot decrease, but displacement can. So this is possible. This is a case of body traveling towards observer. body traveling towards observer. Okay, what about this? What about this? Let's see this one. Let's understand this. This is very important. See, suppose this is the observer. The body was initially at a distance from the observer. So here is the body. So it is at a distance, say 5 meters from observer. The body comes towards the observer. From 0 seconds to say 4 seconds, body comes towards the observer. As body is coming towards the observer, so here as time increases, displacement is decreasing. Okay. Now what happens? Now the body is going onto this side. Body is going onto this side. And that is why you see the displacement is happening on the other side of it. Okay, displacement is happening on the other side of it. So as it is happening on the other side of it, so if this is 0 meter, this was 5 meter. Is this going on this side? That means it is going to negative side. That means 3 meters, say it has gone to 3 meter. So displacement can be negative. Displacement can be negative. So that is why the displacement is gone to the negative axis of y. So as it has gone on the opposite side, so displacement will be negative. Clear? It's very important, very important. Okay. Now another thing, what about the velocity in this case? Absolutely negative velocity. Why? Because the traveling path was on this side. Always on this side, if you see, on this side. So numerically also, if you see, say it is to 5 meter to, let's say this is minus 3 meter. So the displacement has always decreased. The del S is basically minus 3 minus 5, minus 3 minus 5, that is minus 8 meter. Okay, and velocity is del S by del T, that will be negative. Because time is never negative, time will be positive. Okay, clear to everybody, I guess. So this is what displacement time graph is. So I hope everybody of you have understood what displacement time graph is, and definitely we are going to delve into much further action when we deal with velocity time graph and acceleration time graph. So one by one we will do. We are not going to hurry because we are basically doing the chapter of motion in one dimension, and in this chapter we are learning graphs, because normal equations of motion and everything is covered in normal textbooks, but graphs is one thing that we need to cover in our in this course of ours, so that we can absolutely crush any problems that can be done by graphs. Okay, so thank you very much for listening to today's lecture. So stay tuned for many more like this.